Hello, welcome to Target IAS. I am Om Prakash Rajput, and today we are going to start electromagnetic field theory. So, in electromagnetic field theory, we will study three major topics which are electrostats, magnetostats, and time varying field. This electrostats, magnetostats, and time varying field. This is basically the syllabus of ESC, and GATE also same syllabus, electrostats, magnetostats, and sometimes time varying field and Maxwell equation related questions are also there in GATE. So we will study about in electrostats that Coulomb's law, electric field intensity at different locations due to different charge distributions using divergence theorem, electric field and potential due to line, plane, point, spherical charge distribution, and effect of dielectric medium. And then we will find capacitance of some simple configurations also. And in magnetostats we will see Biot-Savart's law and Ampere's law and curl Faraday's law. These all we will see in magnetostats, and using these laws we will find inductance of some configuration. Lorentz force we will study. Lorentz force is basically the combination of electrostatic and magnetostatic force. And then we will move on to time varying field, and we will summarize the whole topics of electrostatics and magnetostatics using the Maxwell equations. So we will see one by one all of these topics. So before starting the topics we will see some basics also which will be required for the for the for the topics which we will study in electromagnetic field theory, like what is unit vector, what is position vector, and how to operate with these vectors. So vector multiplication, del operator, and we will study some basics about the coordinate systems and different coordinate systems also. So let us see few basics first. Few basics. So first is unit vector. So if we see a vector is one which is having its magnitude and some direction and some direction, and that direction is given by this unit vector, given by this unit vector. So we can simply say that is unit vector is a vector which is having magnitude unity, and it is along the direction of the given vector, and it can be find out by this formula, which is a vector divided by its magnitude, a vector divided by its magnitude. So this is the formula for unit vector. By using this we can find out unit vector along any vector. So its magnitude is unity, and it can be found out by a vector divided by its magnitude. Now we will see what is position vector. So for position vector we have to consider a coordinate system. So suppose this is my coordinate system having here x-axis, here y-axis, here z-axis, and I am talking about a point P which is having coordinates x, y, z. These are the coordinates of P, and I join this by origin. So position vector for P will be given by OP vector. It is basically the distance vector from the origin. So it can be simply written as x ax cap plus y ay cap plus z az z az cap. So this is x ax cap plus y ay cap plus a z is az cap. This is from the coordinates of the point P. So this is the position vector for point P. Now if we want to find out a distance vector between 2 points, suppose these are my 2 points, suppose this is P having coordinates x1, y1 and z1, and point Q having coordinates x2, y2 and z2. These are my coordinates for x. These are my coordinates for point Q and point P. So let me join this from the origin. So basically this is OP vector, the position vector for P. This is OQ vector, the position vector for Q, and I want to find this vector PQ. So PQ vector can be found out using OQ vector minus OP vector. PQ vector is nothing but the displacement vector. We are going from P to Q. So what is the displacement from P to Q? It is OQ vector minus OP vector. So OQ vector can be simply written as x2 ax cap plus y2 ay cap plus z2 az cap. Now minus the OP vector, which is, as I have written earlier, it is x1 ax cap plus x2, sorry, it will be y1 ay cap and plus z1 az cap. So if I simplify this, it will come as x2 minus x1 ax cap plus y2 minus y1 ay cap plus z2 minus z1 az cap. This is the distance vector PQ. Distance vector PQ. This is how we can find out the unit vector and the position vector, and also the distance vector for two positions like P and Q. So this is the PQ vector. Suppose this is a question. In this, P point is given and Q point is given. Coordinates of P and Q are given. Coordinates of P are 0, 2, 4, and coordinates of Q are -3, 1, 5. So first part is we want to find out position vector P. So as I have told earlier that position vector P can be written as OP vector because it is reference to the origin, and it will be, the coordinate of x is 0, so it will be 0 ax cap plus coordinate of y is 2, it will be 2 ay cap, and coordinate of z is 4, so it will be 4az cap. This is the position vector P. Now we want to find out the distance vector. Just now we have calculated. It can be find out by the coordinates of q minus the coordinates of p. Respective coordinates will be subtracted, that is -3 minus 0 ax cap plus 1 minus 2 ay cap plus 5 minus 4 az cap, and it will be simplified as -3 ax cap and minus ay cap plus az cap. This is the distance vector from P to Q, that is the PQ vector. Now there is one more part, which is this: a vector parallel to PQ with magnitude 5. First I will write here what was the PQ vector. So PQ vector was -3 ax cap minus ay cap plus az cap. This was the PQ vector. Now we want to find a vector which is parallel to PQ. So first we will find the direction of PQ, so that we can easily find the parallel vector with magnitude of 5. So first we will find, for the direction of PQ, we will find unit vector along the direction of PQ. So unit vector along the direction PQ will be PQ vector divided by magnitude of PQ vector. Magnitude of PQ vector. So PQ vector is -3 ax cap minus ay plus az cap divided by magnitude can be found out by the squaring the respective components and then adding them. So it will be -3 square. -3 square will automatically become +3 square. So we can write +3 also. Answer will be same. Here it will be -1 square plus 1 square. So it will come out as 3 square is 9, 9 plus 1 is 10, 10 plus 1 is 11. So under root of 11. So if I write the unit vector will be -3 by root 11, -3 by root 11 ax cap plus -1 by root 11 ay cap plus 1 by root 11 az cap. This is the unit vector along the direction of PQ. Now we want to find out a vector which is having a magnitude of 5. This vector has a magnitude of 1 because it is unit vector. So now if we want to make the magnitude 5, we will multiply this vector by 5. So the required vector will be if we multiply this unit vector by 5. So 5 into -3 will be -15 by root 11 ax cap. 5 into -1 will be -5. So this will become -5 by root 11 ay cap plus 1 by, sorry, it will also become 5 by root 11 az cap. This is the required unit vector which is having magnitude 5 and direction is along the PQ vector. As we have studied unit vector and position vector, now we will study vector multiplication. If you are given two vectors, then how can you multiply them? So basically there are two ways in which you can multiply the two vectors. First one is scalar product. Scalar product, also called dot product. Also called dot product. If there are two vectors, suppose a vector dot b vector, then dot product of a vector and b product, that is a vector dot b vector, will be a vector magnitude multiplied with b vector magnitude multiplied with cos of angle between them. Suppose these are my two vectors. This is my b vector and this is my a vector, and this is the angle between them. Then dot product of these two vectors will be magnitude of their vectors gets multiplied with the cosine of angle between them. This is dot product. So now if there are basically some conditions, like if theta equals to 0, that is if both the vector are in the same direction, then it will become cos theta will become 1. Cos theta will become 1, and simply we can multiply their magnitudes, we will get the dot product. So now if we use the unit vectors in the direction of, like if we use unit vectors like ax cap dot ax cap dot ax cap will become 1, because these are the vectors in the same direction, that is angle between them is nothing but 0 degree. Like if I make coordinate axis, so this is ax cap, this is ay cap, and this is az cap. So as you can see that ax cap will in the same direction and we will get 1. Similarly if I do ay cap, ay cap dot ay cap, then also I will get 1, and also for az cap dot az cap will be also 1. Now if I do ax cap dot ay cap, this will become 0, as ax cap and ay cap are 90 degree apart. The angle between them is 90 degree. The theta will become 90 degree. So cosine of 90 degree will be cos 90 degree will become 0. So that's why ax cap dot ay cap will become 0. Similarly if I multiply, or if I do dot product with az cap also, ax cap dot az cap, then also it becomes 0, as x and z are also 90-degree apart. Similarly, if I do ay dot az or az dot ax, I will get the same result as 0, because ax cap, ay cap and az cap all are mutually perpendicular to each other. So this is scalar product of two vectors. This is known as scalar product as the product gives the result as scalar quantity. There is no direction in the product. So if you do dot product, then the result will be a simple magnitude or a number. So that's why it is known as scalar product. Now we will see second type of vector multiplication, that is the dot product. Cross product. So cross product is also known as vector product. It is defined as if we multiply two vectors, suppose a vector, and it is represented by cross a vector cross b vector, then it will be a vector magnitude multiplied with b vector magnitude into sine of angle between them, and as it is a vector product, so its result is a vector, so it has a vector quantity. This is the magnitude for this, and this is the unit vector which is perpendicular to both a vector and b vector. Suppose a vector and b vector are in the xy plane, then this a n cap, that is the unit vector normal to the a vector and b vector, will be in the direction of z. If they are in yz plane, then it will be in the direction of x. So this is how we can find out vector product. So here also we can see with the unit vectors like ax cap cross ax cap, ax cap cross ax cap. Now ax cap cross ax cap, angle taken is sine of angle. So angle between them is 0. So sine of angle sine of 0 will become 0. So ax cross ax will be 0. Similarly, ay cap cross ay cap will also become 0, and az cap cross az cap will also become 0. Now if I do ax cap cross ay cap, then it will become az cap, and if I do ay cap cross az cap, it will become ax cap. Az cross ax, this will give ay cap. Now cross product is not commutative, that is a cross b will not be equals to b cross a. In fact, it will be equals to minus of a cross b. That is, if I talk about here, if I like do this ax cross ay is equals to az, if I do the opposite thing like ay cross ax, so I will get minus az, and if I do az cross ay, I'll get minus ax cap, and if I do ax cross az, then it will be minus ay. These things actually we get from the right hand coordinate system. We will see in the coordinate system what is that. So this is all about the vector multiplication, the scalar product and vector product. Now we will study coordinate system. So coordinate system is if you want to locate some point, then we will use coordinate system. If we want to locate a surface or a point, then we will require some reference. For that we will use coordinate system. So we are going to study three types of coordinate system so that it will be convenient for different geometries. So first one is rectangular rectangular or Cartesian or Cartesian coordinate system. Rectangular or Cartesian coordinate system. In this we will be having three parameters as we have seen earlier, x, y and z, for locating certain things. Like if I want to locate a point, suppose I draw here a cube. Suppose I am talking about this point. So at this point having coordinates x comma y comma z. This point having coordinates x comma y comma z. So this coordinate having x comma y comma z, and first of all I will mark where is my x and y and z. So this is my x, y and z axis. So this is my x, this is my y and this is my z axis. So the point P has x, y and z coordinates, that is the distance from here to here will be y, and the distance from here to here will be x, and this height of the cube will be z. This height of the cube will be z. So if I want to locate this point P, then I will require certain specific values of x and y, x, y and z. Like if I talk about this point, then it will have some different values of x, y and z, but for this point it will be some specific values. That is, we can say that for a point, if we want to locate a point, the values of x, y and z, that is all the three parameters in a coordinate system, all three parameters are constants. All the three parameters are constants. There will be no variable required to locate the point. No variable. Now, if I want to locate a line, suppose I want to locate a line, then how can I locate a line? Suppose from this cube I will locate a line, like this is my line. So for this line you can see there is specific value of z. If I extend this further, this is a line, there is specific value of z, and there is specific value of y also. There is specific value of y also. For every point on this line there will be specific values of y and z, but there will be different values for x. Like if I see here, at this point there will be different values, at this point there will be different value for x, at this point there will be different value for x. So at each point there will be different values for x. That is, for a line, for a line for a line there are two parameters which are constant. Like in the given example, my constants were y and z, and one variable. So if I want to locate a line, then I have to specify two constants and one variable from the given three parameters. Now if I want to locate a surface, if I want to locate a surface, so for surface, for a surface, if I talk about this surface, you can see for this surface the variable y is constant. At every location the value of y will be constant, but suppose I take this point, the value of x will be different. If I take this point, value of x will be different. If I take this point, value of x will be different, and also the value of z is also different for this point and this point and this point too, but the value of variable y will be same for every point on this surface. So we can say that for a surface, one constant from the three parameters, one is constant and two variables are required. These are applicable for any coordinate system. Like for a point, we will have three parameters, so all three will be constant. For a line, one will be variable and two will be constant. For a surface, one constant and two variables. Similarly, we can see some other surface also. Like if I talk about this surface, the upper part, so for this surface the value of z is constant and the value of x and y is varying, you can see. Now for volume, like if I consider this cube to be my volume, there will be different values of x, y and z for every point. Every different point there will be different values for x, y and z. So all three are variable. All the three parameters are variable, and this is applicable for all the coordinate system. All three parameters are variable for a volume. Now if I talk about the range for the values of x, y and z, so if we want to cover the whole universe, then value of x will vary from minus infinity to plus infinity to cover the whole x-axis. Value of y will be from minus infinity to plus infinity to cover the whole y-axis, and similarly value of y will be from minus infinity to plus infinity to cover the whole z-axis. In this way we can cover the whole universe using this rectangular coordinate system with these ranges. Now we will see the second type of coordinate system, cylindrical coordinate system, and we will use this coordinate system in symmetries. Like if we are doing a problem on a wire or a pipe, then we will use this system. So in this cylindrical system there will be three parameters. There will, like the same as in rectangular coordinate system, there were also three parameters. In all coordinate system there will be three parameters. So here the three parameters are rho, phi and z. Rho is the distance, rho is the distance from the z-axis. Rho is the distance from the z-axis. If I talk about this point, if I talk about this point, so suppose this point is P having coordinates rho, phi and z, then rho will be distance from the z-axis. That is, we can say that this distance from here to here, it will be rho. Rho is also known as radius of the cylinder. Rho is also known as radius of the cylinder. because this is a part of the cylinder. If we complete this, so this will be a radius of the cylinder. Now we will see what is phi. So phi is the angle with the z axis. This line, this blue line, makes an angle with the x axis, that is known as phi. So for the angle with x axis, I have to take this line in the xy plane. So if I project this line on the xy plane, then this angle will be phi angle. This is also known as azi azimuthal angle. Azimuthal angle. And z is same as in the Cartesian coordinate system. So if I want to find the range for this, for these parameters, range. So if I want to cover the whole universe, then value of rho will vary from 0 to infinite. So if you imagine a infinite size cylinder having infinite height and infinite radius, then it will cover the whole universe. So now phi, for phi, it should cover the whole circle. It should cover the whole circle. So for phi, the range will be from 0 to 2 pi. The range of phi will be 0 to 2 pi, and z will be similar to the Cartesian coordinate system, that is from minus infinity to plus infinity. So this is about the range of the cylindrical coordinate system. Now if I talk about the relation with the cylindrical coordinate system with the rectangular coordinate system. So if I want to convert the rectangular coordinate system parameter, rectangular to cylindrical, rectangular to cylindrical, then you can see here, if I want to convert rectangular to cylindrical, so that is, I want to find what is rho in terms of x, y and z. So you can see here, this is projection of rho from here to here. So if I consider this triangle, if I consider this triangle, this is a right angle triangle where this is 90 degree, and rho is acting as hypotenuse of this triangle. So this is x, and this will be same as y. This will be same as y. So using the Pythagoras theorem, it will be rho square equals to x square plus y square, or we can write rho is equals to under root of x square plus y square. Since it is the radius, it cannot be negative. So rho is equals to under root of x square plus y square. We are considering only positive value. So now if I want to find phi in terms of x and y, then you can see in this triangle, same triangle. If you find tan phi, that will be y divided by x. So phi is equals to tan inverse y by x, and z is equals to z. Now if you want to do the opposite, if you want to do the opposite, that is cylindrical to rectangular, you can find the values of x and y in terms of rho and phi. So you can see that this is rho. If I project this on the x axis, then it will become rho cos phi. So we can write that x is equals to rho cos phi, and if I project rho on the y-axis, then it will become rho sin phi. So we can write y is equals to rho sin phi. We can write y is equals to rho sin phi, and z equals to z. So this is how we can relate cylindrical to rectangular, and this is how we can relate rectangular to cylindrical. Now if you want to see the unit vectors of this, it will be like this. So arrow cap arrow cap will be in the direction of increasing radius, will be in the direction of increasing radius, and a phi cap will be anti-clockwise. A phi cap will be anti-clockwise, completing the circle, and az cap will be in the direction of increasing z value. So you can see that arrow cap, a phi cap, and az cap all are mutually perpendicular with each other. All are mutually perpendicular with each other. As in the case of as in the case of rectangular coordinate system, the ax cap, ay cap, and az cap, all the three parameters unit vector were perpendicular to each other. Here also all the three unit vectors arrow cap, a phi cap, and az cap are mutually perpendicular. So their dot products like arrow cap dot a phi cap, or a phi cap dot az cap, or az cap dot a phi cap will be 0, and arrow cap dot arrow cap will be 1. Similarly we can do this as in the case of rectangular coordinate system. Now we will study about spherical coordinate system. In spherical coordinate system also there are three parameters r, theta, and phi. Suppose I am taking this point P having coordinates r, theta, and phi. So what is r? R is the distance from origin. From origin O to P, the distance from O to P is r. So basically we can also say that r is a radius of the sphere. R is radius of the sphere, and distance from origin, from origin, also radius of the sphere, radius of the sphere. The angle with the z axis, here it is x, here it is y, here it is z axis. Angle with the z axis is the theta. Angle with the z axis is the theta. So this is angle with z axis, and phi is similar to the Cartesian coordinates. If I project this OP on the xy plane, if I project this OP on the xy plane, then this distance from here to here, it will be rho, and this angle with the rho will be phi. This angle with the rho will be phi. Now if we see the range for all these parameters, so as r is the radius, it can vary from 0 to infinity. You can imagine an infinite size sphere to cover the whole universe. Here limits of phi will be same as in the case of cylindrical coordinate system, that is from 0 to 2 pi. And for theta, theta is the angle with the z axis, so this line OP can go from up to down. So to cover the entire z axis with this line, theta should vary from 0 to pi. So these are the ranges for the cylindrical coordinate system. Spherical coordinate system. These are the ranges for spherical coordinate system. Now if you want to find the relation with the rectangular to cylindrical, or cylindrical to, rectangular to spherical, or spherical to rectangular, or cylindrical to spherical or spherical to cylindrical, we have to see, we can also do that, like first we will do rectangular to spherical, rectangular to spherical. So we will find r, theta and phi in terms of x, y and z, in terms of x, y and z. So you can see that this is r, and I have written coordinates of P in terms of x, y, z, rho phi z and r phi z, like in all the three coordinate system. So the value of r is from the origin to P. If I want to relate r with x, y, z, I have to see this triangle. Like if I see this triangle from this to this, if I take this point as uh, B and take origin as O, then triangle OPB is a right angle triangle. The right angle is this, and R is the hypotenuse. So we can apply Pythagoras theorem in this. So for Pythagoras theorem, R square will be equals to this distance. This distance is nothing but the height of this. So it is the Z. So PB is Z, and what is OB? OB is the R vector projection on the xy plane, that is the rho, and rho we already know that it is under root of x square plus y square. So we can write r square will be equals to rho square. Rho square is nothing but x square plus y square and plus z square. So we can write r is equals to under root of x square plus y square plus z square. So this is how we can relate r in terms of x, y and z. Now if you consider this triangle OP, suppose this point is C. If you consider OPC, then this is the angle 90 degree, and if I project this line R on this, it will be R cos theta, that is Z will be R cos theta. We will use this Z equals to R cos theta to find the theta, and cos theta will be nothing but Z divided by R. Cos theta will be similar, it is trigonometric properties that cos theta is equals to base upon hypotenuse, and here base is Z and hypotenuse is R, and R we have already related in terms of x, y, z. So we can write theta in terms of x, y and z. So Z equals to, oh sorry, theta equals to Z divided by R. R is x square plus y square plus z square under root. So this is the value of theta. This is the value of theta, and this is the value of r. And we have already related phi. We have already related phi in terms of y, x and y in the cylindrical coordinate system. So it will be similar here also. So phi is equals to tan inverse y by x. Phi is equals to tan inverse y by x. So this is how we can relate rectangular. This is how we can relate rectangular to spherical. Now, if you want to do the opposite, that is from spherical to rectangular, from spherical to rectangular. So now, if you want to do spherical to rectangular, then we will relate the x, y, and z. We will find out in terms of r, theta, and phi. So we can see that if I project this r here, if I project this r here, so it will be r sine theta, and this distance from here to here, origin to point B, this is r sine theta. And then again if I project this on x-axis, then it will be r sine theta cos phi. R sine theta cos phi. So I can write x is equals to r sine theta cos phi. Similarly, I can write, if I project this line OB on the y-axis, so OB was r sine theta, and if I project this line on y-axis, it will be r sine theta sine phi. So I can write y is equals to r sine theta sine phi. R sine theta sine phi. And if I project this r on the z-axis, this will be r cos theta, and this is z, so it can be written as z is equals to r cos theta. So this is how we can convert spherical to rectangular system. Now we will see from cylindrical to spherical. Now we will relate r theta phi in terms of rho phi and z. So we can see that if I project r on the xy plane, this distance is rho. From O to B is rho. So rho will be r sine theta. Rho will be r sine theta. Sorry, I want to relate r with the rho phi and z. So consider this triangle OCP, origin C and P. This is a right angle triangle. Here I can write with the help of Pythagoras theorem. Here I can write with the help of Pythagoras theorem that r square will be equals to rho square plus z square. That is, we can write r is equals to under root of rho square plus z square. In the same triangle we can find out theta also. Theta here will be tan inverse of rho by z. Theta equals to tan inverse of rho by z. And phi is will be same as the Cartesian as the cylindrical coordinate system, so phi will be equals to phi. Now if you want to do the opposite, that is from spherical to cylindrical, spherical to cylindrical, spherical to cylindrical, that is, we will be relating rho phi and z in terms of r theta and phi. So now if I project this line OP on the xy plane, so it will be r sine theta, and this distance is already rho. So we can write rho is equals to r sine theta, and phi here will be equals to phi, and z will be, if I project this line OP on the z axis, it will be r cos theta. So this is how we can relate rho phi and z in terms of spherical coordinates, that is r, theta and phi. Now as in the other coordinate system, rectangular and Cartesian coordinate system, the unit vectors ax cap, ay cap and az cap were perpendicular to each other. A rho cap, a phi cap and az cap were perpendicular to each other in the cylindrical coordinate system. In spherical coordinate system also, the unit vector ar cap along the radius of the sphere is perpendicular to the theta. A theta cap is perpendicular to a phi cap. Here also all the three unit vector are mutually perpendicular to each other, that is, their dot products also, that is with the same components ar cap dot ar cap or a theta cap dot a theta cap or a phi cap dot a phi cap will be equals to 1. If I do the different thing like ar dot ar cap dot a theta cap, or if I do a theta cap dot a phi cap or a phi cap dot a r cap, then they will become 0. It will become 0 because they are mutually perpendicular to each other, and dot product in dot product cos of angle is taken and cos of 90 is 0. So that makes the dot product of these to 0. Now if I talk about the cross product of the unit vectors, then in Cartesian coordinate system, ax, ay, az will follow this rule. If I take the cross product of ax cross ay, I will get az. If we go in the like ax cross ay, I will get az. If I go az cross ax, I will get ay. And if I go in the opposite direction, that is clockwise direction, then suppose I am taking az cap cross ay cap, az cap cross ay. If I talk about az cross ay, then it will be minus ax cap, because the system we use is right hand circular system. That is, if we curl our fingers in the if we curl our finger of right hands, we will get the respective unit vector, like az cross ax will get you ay, and ay cross az will get you ax. Similarly, for the cylindrical coordinate system also, here a rho, a phi, and az. So if I take cross product of a rho cap with a phi cap, will give you az cap, and a phi cap cross az cap will give you a rho cap. If I do the opposite, suppose I am doing a rho cap cross az cap, I am moving in anti-clockwise, I will get minus a phi cap. So we have to move in anti-clockwise direction to get the positive unit vector, and if we do in the if we do in the clockwise direction, we will get a negative unit vector. So same in the case of spherical coordinate system also. Here ar, a theta, and a phi. So if I take ar cap cross a theta, I will get a phi cap, and if I do the opposite, that is the in the clockwise direction, a phi cap cross a theta, I will get minus ar cap. So this is all about the introduction of basic things, and we will meet in next lecture. Till then,